Standing on the edge of the Giza Plateau, the Great Pyramid Standing on the edge of the Giza Plateau, the Great Pyramid of Giza defies the passage of time. It is a structure composed of roughly 2.3 million stone blocks, some weighing as much as 80 tons, assembled with a precision that modern engineers struggle to replicate. For generations, the orthodox narrative has been clear. This was a tomb for the pharaoh Khufu, built over 20 years using copper chisels, hemp ropes, and a workforce of 20,000 men. But as we move into the middle of the 2020s, that narrative is fracturing. When you look closely at the masonry, a disturbing and illogical truth emerges. The timeline of Egyptian progress appears to be backwards. The Great Pyramid, the largest, most complex, and most precisely aligned structure in the world, is ostensibly the product of the 4th dynasty. Yet the pyramids that followed it, built by subsequent pharaohs with more experience, are dramatically inferior, many now reduced to crumbling piles of rubble. It is as if a civilization mastered the impossible overnight and then immediately forgot how to do it. Why does the archaeological record show a sudden peak in technology rather than a gradual evolution? What is the forbidden evidence within the internal chambers that challenges the dating of the structure? And most importantly, if the dynastic Egyptians were not the original architects, who or what left this anomalous mountain of stone behind? The scientific origin of the Giza controversy lies in the backwards evolution of the Old Kingdom. In a standard technological progression, we expect to see improvement over time. However, at Giza, we see the opposite. The step pyramid of Djoser shows a clear experimental phase of masonry. Then, suddenly, with no intermediate prototypes, the Great Pyramid appears, a structure aligned to true north within 3/60ths of a degree. The turning point in modern skepticism arrived with the geological analysis of the nearby Great Sphinx. In the early 1990s, and reinforced by studies in 2025, geologists identified deep, vertical fissures on the body of the Sphinx and its enclosure walls. These are characteristic of precipitation-induced erosion, damage caused by thousands of years of heavy, persistent rainfall. The problem? Egypt has been a hyper-arid desert for the last 5,000 years. For the Sphinx to show this level of water weathering, it would have to have been carved at the end of the last ice age, at least 10,000 BCE, 5,000 years before the Egyptian civilization even began. If the Sphinx is 10,000 years old, the entire dating of the Giza complex must be reassessed. This is not just a minor error, it is a 5-millennium gap that traditional scholars refuse to bridge because it threatens the very foundation of established history. To understand the technical core of the mystery, we must move beyond the copper chisel theory. The Great Pyramid's interior, specifically the King's Chamber, is lined with massive red granite blocks transported from Aswan, over 800 kilometers away. These blocks are cut with such precision that the joints are invisible to the naked eye, often less than 0.5 millimeters wide. Modern engineering data from 2026 suggests that to achieve this level of accuracy in granite, one of the hardest stones on Earth, requires more than manual labor. High-speed circular saws and ultrasonic drilling are the only modern equivalents that produce similar feed marks found on some of the discarded granite fragments in the Giza debris fields. Furthermore, the pyramid is not 4-sided, but 8-sided. A subtle concavity in each of its 4 faces, visible only from the air during the equinoxes, reveals a level of mathematical and astronomical planning that surpasses anything recorded in 4th dynasty texts. The forbidden evidence scholars often ignore is the lack of inscriptions. In every other Egyptian temple or tomb, the walls are covered in hieroglyphs praising the gods and the pharaoh. The Great Pyramid is entirely silent. There are no original inscriptions, no murals, and no mention of Khufu within the primary structure.